Hi. Okay, so I could make it work and do this project, and I will soon show you how it is connected. But I have found a few things that you might need to know. First of all, I try to connect it, as I said in the previous lesson, directly to the LED through resistor and to ground. But this gave me a very low light. And then I connected it in the other way from P0 till P7 to the cathode of the LED, and then to resistor, and then to VCC, and this gave much brighter light. And then I of course checked the data sheet, and I could find the problem that caused this problem. If you can see, the I out low, continuous low current, is 50 milliamp, while the I out high, the connection that gave me very low light, is just minus 4 milliamp. So this connection is not good. You can use it if you have a relative low current consumption, something that you want to drive, but it is not good for the LED. So if you want to connect this chip to the LED, you need to connect it to the cathode of the LED and anode to a resistor and then to VCC. Otherwise it will not work well. The other thing that I found, that the address are not right. Why the address are not right? Because the I2c driver that we have in Arduino doesn't take in count bit number 0, meaning it looks just the address from A0 and just 7-bit, meaning that everything that you see here, you need to shift right 1 bit. Why is that? Because if I will take these bits and I've connected all to 0, so I have address number 2 and then 0 in hex, or if you want in binary, so it will be 1 2 4 8 16 32. Okay, so it is 32 in decimal, or in binary you just need to input all the bit, which will be 0 0 0 0 0 and then 1. And now I found this by using a I2c scanner. Somebody wrote this very nice program. This program just scan the I2c and wait for transmission back, and by this it can give you all the addresses of the equipment that is connected to I2c. So I've connected this and found out that my board was on address 20 hex. By the way, I can show how it is working. So I will burn this code to my board. I will put it later. This is not mine. Someone wrote it. And then if I will put the serial monitor, so you will see that the I2c scanner is scanning and finding address 20 hex. So I knew that the first address that I put was wrong. This is why the board did not work for me at the beginning. Later on, I wrote this very simple program, and I had to do another change in order to count binary. Now I need to take in count that all the logic is negative and not positive, meaning I have to drive 0 in order to get the LED on. So I took that the first number is 255, which means all the output will be 1, and then in the connection that is recommended, if I drive VCC to this point, so the LED of course will not light. So it is starting for 255. It is doing a first setup to the address 32, and then I'm writing 85. Why 85? Because I wanted to have one LED off and one LED on, one LED off and one LED on, in order to see that my software is working correct. I will explain in the calculator why is 85. So let's take the calculator and move it to programming, and then we'll put in decimal 85, and we can see in binary that it is 01010101. Okay, so this is the reason that I decided first to put this number. After, it is just doing a delay of half second, and then writing to the address, and then writing the number, and this is a stop bit, and count minus minus, and it is going over and over again. So this is a very simple program that is running. I will put a link later, and by this you can do of course whatever you want with this board, and activate maybe if you have relay or something that you want to control from your Arduino software. And I think that this covers all the I2c parts. Another thing that I had to do in the board is of course to set the address. This is the last thing, because if you get the board, so the addresses is connected to pads that there is nothing in the pads. So if it is not connected, I don't know how the chip will consider this. If it is 0 1, so I connected all to 0 in order to get the address 32 that I'm talking about. So I will try maybe to find a picture of the board to show it. Okay, so in this board you can see it. You can see it, so you can see it. So here we have 3 unconnected. It is not connected to anything. So if it is not connected, so I don't know what the address is. So what I did is just put solder all together to all this part, because this side is ground, and this is address 1, address 2, and address 3, or it is started from address 0, I don't remember. So I just put one big solder here, which connect all the address from the chip to 0, and then it is all set to address 32. Okay, so it is A0, A1, and A2. And that's all. And now I will show you how it is working and discover this explanation about working with this board. But don't forget that you have a P3 to put it disconnected from the board in order to get LED number 4 working for you. Thank you and bye bye. Okay, so here's the demo of the circuit I've built. Now I will connect power to the Arduino board, and you will soon see the LEDs starting. As you can see, it is counting in the binary way. By the way, if you can see the red LED, we have a red, orange, and I've also put a green in the middle. I've put the green because I found out that in this board it seems that one of the pins is not connected. and the pin that is not connected is output pin number 7. Output, let me check to verify. Output, yes, pin number 7, which is P3, or the fourth bit. The bits, by the way, are going from LSB to MSB here. So this is like a binary digit F0, and then digit 1 and 2 and 3, 4, 5, 6 and 7. So what we can see here, that I had to lift up pin number 7 and then connect it to the green wire, because when it was soldered in board, so it seems that the LED was continuously lighting, the green one. So I lift it up because I guess that this is something in the board that I have to disconnect in order to make it work. And as you can see, this is a breadboard with all the LEDs connected, and it gets the I2c commands directly from the Arduino Mega board, which is here. I will put it in the camera so you will be able to see it. So this is regular Arduino 2560. I think it is a revision 3 board, and I have had to connect the SDA and SCL from the board. We have the SDA and the SCL on output number 20 and 21. 20 is the SDA and 21 is the SCL. The other wires are connected just to 5 volts output. Additional things, the I2c that I picked is from the directly from the chip, but you can use, of course, and write your I2c through any digital output and do it by yourself. If you are a little more skilled to write it, this is not a very complicated task to do. And that's all. Thank you.